Now we're going to do a bunch of examples to find the antiderivative. Number 1, let's find the antiderivative of x cubed dx. We're going to use the reverse power rule. So in the beginning of the lesson, we talked about the reverse power rule. The first thing we're going to do is add 1 to the exponent. And then we're going to divide by that new exponent. And then we tack on a constant of integration. You can always find the derivative of your answer to make sure that it equals the integrand to see that you're doing it correctly. Number 2. Okay, we're going to find the antiderivative of 5x cubed minus 2x squared plus x with respect to the variable x. Okay, let's do our reverse power rule. So it's 5x to the power of 4, I added 1 to the exponent, and I divide by the new exponent, minus 2x, add 1 to the exponent, divide by the new exponent, plus x, add 1 to the exponent, divide by the new exponent, plus c. That's our antiderivative. That's our parent function. Okay, example number 3. Let's do x to the power of 5 minus x cubed over 2 plus 2x plus 1 dx. X to the power of 6 over 6 minus x to the power of 4. I already have a 2 in the denominator, so now it's 2 times the 4, which is 8, plus 2x squared over 2, plus, and I think what gives me the derivative of 1? Well, simply x plus c. Now, I will simplify this just a little further, and lots of times you can just do this in your head without an extra step. See, the 2's cancel out, so I have just x squared and then plus x plus c for my antiderivative. Example number 4. Let's find the antiderivative. 8x to the power of 3 plus 2 cosine of x dx. Okay, so this is a combination of the reverse power rule and book of memories. Okie dokie. So we're going to have 8x to the power of 4, and then I'm going to divide by the 4. But when I divide by the 4, it's going to reduce the 8 over 4 to simply be 2. Then it's plus, and now I have this 2 in front of a trig, and it's going to get pulled out as 2. And then the antiderivative of cosine of x is simply the sine of x plus c. I can't emphasize enough that if you want to check your answer, you simply take this derivative. So that would be 8x cubed plus 2 cosine of x, and that would be the end of it, which then matches with the integrand here. Example number 5. The integral of 7x cubed minus 6 radical x plus 1 over x cubed dx. Before doing this antiderivative, let's just write it in a form that makes the reverse power rule a little easier. So I'll say 6x to the 1/2 power plus, now this is going to be x to the negative 3 power and then dx. So now we're ready to do the antiderivative. 7x to the 4th over 4 minus 6x to the, alright, let's raise this by 1, so that becomes a 3/2 power. And then I have to divide by the new exponent of 3/2. But instead of dividing by 3/2, let's multiply the reciprocal. So times 2/3. Then we have plus, and then it's x to the, well, careful, when we're increasing it by 1, it becomes negative 2. And then I'm dividing by the negative 2 and adding the constant of integration. Let's clean this up a little bit. 7x to the power of 4 over 4. Well, 6 goes into 3, or 3 goes into 6 twice, so that's going to give me minus 4x to the 3/2 power. And then I have plus negative, so I'll say minus x to the negative 2 over 2 plus c. You are certainly permitted to write this term as minus 1 over 2x squared. I don't mind if you leave the negative exponent, so you can write it that way, or you can write it this way. Number 6. Okay, here we go. 5x to the power of 5 plus 1 over x plus the secant squared of x plus 1 over 1 plus x squared minus e to the x plus 2 dx. In a moment, press pause, see if you can answer this, and then unpause it to check your answer. Press pause now. Okay, if you're coming back to me, we are ready to find the antiderivative. 5x to the power of 6 over 6. I would like to highlight this one here for a minute. In the event that you wrote this one, x to the negative 1 power dx, well, then you would have written x, you would have added 1, which is 0, divided by 0, but you can't divide by 0. When we did the reverse power rule, we said it's x to the power of n minus 1 over, n plus 1 over n plus 1, except n plus 1 cannot equal 0. So that was the case here. N cannot equal negative 1. So this portion here, you could not use the reverse power rule. What you should have noticed was this was simply the derivative of natural log. So the antiderivative of 1 over x is simply natural log of absolute value of x plus. Now we're up to this one. Antiderivative of that, tangent x. The antiderivative of the next term, inverse tangent of x. All book of memories, minus e to the x plus 2x plus c. Don't forget the c. Number 7, antiderivative of sine of x minus 2x to the power of 3 plus 1 over x squared minus 1 over x plus 3 over the square root of 1 minus x squared. All of that with respect to x. Here we go. Press pause now. And we are going to do the answer. Okay, the antiderivative of sine of x is negative cosine x minus 2x to the power of 4 over 4. Looks like that reduces to x to the 4th over 2. This one, I should have written it as x to the negative 2 power. So it's going to be x to the negative 1 power divided by negative 1. Then I have minus natural log absolute value of x plus, then it's 3, and then the derivative of 1 over square root of 1 minus x squared. You should have that committed to memory as inverse sine of x plus c. Last example of this type. Why don't you go ahead and try this? Press pause now. Okay, this one is the easiest one on the page. See this little derivative out front? Perhaps you didn't see that. And that's what makes the problem super easy but super tricky, because you don't see the dx in front of it, then suddenly you don't realize how easy it is. This is the derivative of the antiderivative, so it's simply the function itself. E to the cosine x plus 1. No plus c. This is the last part. We're solving differential equations. So here I give you a derivative. dy dx equals 6x squared plus x minus 5. But there's some other information. They say y equals 10 when x equals 2. And the point of solving a differential equation is to find not just the general, the family of functions that work, but to find the one particular function that satisfies this derivative and has this condition. So let's do this methodically. The first thing I'm going to do is I'm going to multiply both sides of the equation by this dx. So now I have dy equals 6x squared plus x minus 5, and I have to multiply that by dx. The next thing I'm going to do is rewrite this for the purposes of notes. I want to rewrite it so I know the order which I did things, and then I'm going to take the antiderivative of both sides. Okay, let's take a look at the left-hand side. The antiderivative of dy is y. It's actually y plus c, but I'm going to hold off on the plus c for a moment. Now I'm going to take the antiderivative of the right-hand side, and that's going to be 6x cubed over 3, which reduces to 2x to the power of 3, plus x squared over 2 minus 5x plus c. Now I have the plus c. The reason I don't need the c on the left, I could have said y plus c equals 2x cubed plus x squared over 2 minus 5x plus c. But then I could have taken this and subtracted both sides. These are different c's. Then I'd have this c2 minus this c1, which together collect to be a new constant of integration. So what we have found here is the general solution. General solution, which is what we've been doing in the entire lesson, finding the antiderivative. We found it for a whole family of functions, so that could be plus 5, plus 10, minus 7 for any constant. But to solve a differential equation, we want to find the one function that has this as its derivative and satisfies some condition. So what I need to do here is I need to plug 10 in for y, and I need to plug 2 in for x. When I do that, I'll get this expression here, and then I just have to do a little bit of arithmetic to solve for this constant. And after I do the arithmetic, it turns out the constant is 2. Once I have that information, I have successfully found the particular solution. It's one function that works, plus 2. So that is my final answer. This is the particular solution. This is the solution to the differential equation. Let's take a look at the second one. This time I'm giving you a second derivative, f double prime of x, and ultimately I want to find f of x, solving for a couple of constants along the way. So the first thing I need to do is find f prime of x. So f prime of x is the antiderivative of f double prime of x. So I'll need to take this antiderivative. So that's going to give me a 5 sine of x minus 2 cosine of x plus c. Now I have a condition. I know that f prime of x, f prime of 0 is going to equal 4 when x equals 0. And this will tell me that c equals 6. Now I'll rewrite this. So f prime of x is 5 sine of x minus 2 cosine of x plus 6. But now I have to find f of x, which is the antiderivative of f prime of x. And so we'll do the antiderivative of this. And that will come out to be negative 5 cosine x minus 2 sine x plus 6x plus c. Now I must use the f condition. F of 0 is equal to 3, so it's going to be negative 5 cosine of 0 minus 2 sine of 0 plus 6 times 0 plus c. And simplifying this, it'll tell me that c is going to come out to be positive 8. And now I have solved my differential equation. I have my particular solution, negative 5 cosine of x minus 2 sine of x plus 6x plus 8. Okay, here's our next example. Remember, the first thing we do is multiply both sides by the dx when written in Leibniz terms. like that. We're going to integrate both sides. I would like you to do this one all by yourself and then check your answers. So press pause now. And here is the answer. My C was -3/4. And then I box the particular solution. F prime of x equals 5e to the x plus 1 over 1 plus x squared plus 4, with the condition that f of 0 equals 6. I would like you to solve this. Find the particular solution. Please press pause now. And here is the answer revealed. E to the 0 is 1, and inverse tangent of 0 is 0. My C was 1, and I've boxed the particular solution.